Hi, welcome to Space Club, where every month in this series, I, Anastasia, will feature two sessions on the same topic. One live stream interactive conversation with guest expert, where you will be able to ask questions in the chat while the expert answers them live. And second, a follow-up Zoom meetup with the same expert, where you will be able to ask questions directly and engage in a lively discussion. Thank you, American Center in Moscow, for this opportunity. So today we will talk about Mars exploration through analog programs. How has the Mars environment been simulated on Earth? How many different Mars programs on Earth are actively helping to create the basis for human Mars exploration? Our expert on that is James Burk, the Executive Director of Mars Society and leading the setup of the Mars Technology Institute. His responsibilities include managing the Mars Desert Research Station in Utah and the Flashlight Mars Arctic Research Station in Canada, both critical for Mars analog research. He commands Transatlantic Mars Desert Research Crew 261, and a notable mission in analog astronautics, which was featured on CBS and Northwest Aerospace News magazine. With background as Microsoft engineer and technical project director, James Burk combines broad technological expertise with deep passion for space exploration. James, hi.
Hi, Anastasia. It's so great to be with you today.
How are you doing?
I'm doing great. There's a lot going on, but it's always fun to talk to a new community, and I'm really excited about today's event.
Thank you so much for having time. And we have mostly in our audience students and people from Russia, and they're very passionate also about space exploration since, Yuri Gagarin times, and they would love to know more about how, Mars analog station that you have in USA actually helping for the Mars exploration.
Yeah, it's fantastic to talk to the folks today in Russia, and I'm so excited and honored to be with you. The Mars Desert Research Station and the Flashlight Mars Arctic Research Station are two analog research bases that the Mars Society operates. And the Mars Society, we're a global nonprofit headquartered in the United States, but with chapters all around the world. We have chapters in over 45 countries. And our two stations we built in the year 2000 and 2002. And we first built the Arctic Station on Devon Island, which is way up in the Arctic Circle in Canada. It's actually on indigenous land called Nunavut. And so we coordinate very closely with the tribal council to get permission to use their land and to conduct our scientific research there. We actually have a crew going up there, a crew of 7 international crew going up there in 2 weeks, and They'll be staying for about a month. And a couple of them were on the crew last year. The commander, Terry Trevina, was on the crew last year that we went. And of course, Anastasia, you also visited the station.
Yes, I was there in 2017 for a month, and it was, I think, one of most unforgettable experiences because you live on an uninhabitable island in the middle of nowhere. So you really have the feeling that you're on a different planet.
Yeah, it's an island the size of Ireland, and it's pretty much uninhabited, although the indigenous folks do come through there and hunt and fish. But we watch out for polar bears. We always kind of do a flyover before the crew lands to make sure there's no polar bears roaming around. But it's a fantastic place for science because there's a huge impact crater there called the Houghton crater. And NASA had been going out there since the 90s.
And it was impacted by meteorite, right?
That's correct. It's one of the best preserved impact craters in the world. That's pristine and a direct hit. So you can really study an impact like that.
And hopefully on Mars, we're not going to have a polar bear. So minus one of the dangers. Maybe you have a picture of Flashlight Station that we can show.
Yeah, let's pull up my slides here. I'm not going to go through all the slides today. This is from a presentation I gave in Los Angeles a couple weeks ago. If you go to the next slide, This is actually the station in Utah we're going to see first. I'll go ahead to the next couple. This is the Flashline station, and that was our crew from last year. We had a crew of 5, one Australian, one British person, and 3 Americans. And they went up there to reactivate the station. We actually hadn't been there for a few years since your mission, Anastasia. And so we needed to make sure all the gear was still working. We brought some extra supplies and extra fuel, spare parts, a couple new ATVs as well. And they spent the good part of a month there. Also cleaned out the station top to bottom and just tried out all the equipment. And then they had a fantastic mission. And so now we're prepared to go back and do follow-on research.
Can we talk, more about the limitations of this station? Because you have to rely only on yourself. And I know that if something happens to you and the weather is bad, you have to wait a few days for the help for a plane to arrive.
Yeah, I'll just put this slide up as I'm talking, but basically, yeah, it is a very remote location. It's a challenge to get to. We have to fly these Twin Otter planes, which you can see in the bottom right, to get to our location. And we fly those out of Resolute Bay, which is a very small hamlet, not even a town. It's a small village up there in Nunavut. And then we take commercial travel from various places to get to Resolute from Iqaluit or Yellowknife, Canada. But it's very costly, and also, we have to be really mindful about what we're bringing and what we're having to haul away, because we can't leave any trash there. We can't leave anything that's going to disturb the environment, and so we need to be very careful and plan out what we do.
And with this comes the funny stories of how you're recycling your number 1 and number 2, how you go to the restroom. I remember the furnace that we've been burning our poo there.
Yeah, there's all kinds of challenges at both of our stations about just operating as a normal, professional or scientist or student. In those environments. I mean, the Arctic, obviously, there's very limited supplies. You can't order DoorDash or order food from a restaurant and have them deliver it to you. You have to bring everything with you. You have to bring anything you're going to need to do your job for a month, as well as your clothes and ways to communicate home. We have Starlink that we use. We also had satellite phones using the Iridium system to communicate as a backup. But we were able, with Starlink, we actually were able to do some Zoom calls with schools in Australia and the Arctic last year, which was great.
Amazing.
Also, we did an event in Kenya, between Kenya and the Arctic, which I was actually a part of as well in Seattle, Washington, in the US.
That's great. Thank you, Starlink. When I was there, we didn't have internet much, so and I know that also if something breaks, you rely only on yourself, on your crew to fix it and to continue working. And I think it's also the same mentality that we will use on real Mars missions.
Yeah, absolutely. I mean, some of the things we've learned at the Utah station here is how to keep all this equipment up and running when we're constantly using it almost year round. We've done 22 field seasons now at the Mars Desert Research Station in Utah in the United States. And we've had 300 crews and over 2,000 crew members. Now, 2 of those people have reached space. Cyan Proctor and Jessica Watkins have both become real astronauts after coming through our program. And we hope that's the first 2 of many more.
Yes, I hope so too. I hope one day I can be in this list. And you too.
I'm sure you will be, Anastasia. I have no doubt about that.
I would love to go with you on a real space mission.
Yeah, that would be an amazing adventure. I'd love to do that.
Can you talk a little bit more? We look at this picture. What the different modules that we see here?
Well, there's the main building is the habitat. This is meant to be a 2-story structure that represents a spacecraft that has landed on Mars. This would be the top of the Starship rocket or the SLS or some large heavy lift rocket, brought that capsule, that habitat, all the way to Mars, and the crew probably lived in it during their flight to Mars for 9 months. They land, that represents their home on Mars. That's the main building. The upper deck is the kitchen and common area, as well as there are 6 staterooms. So each crew member typically has their own room with a bed and a desk. It's very tiny. It's like, the kind of quarters you'd have on a Navy ship or a submarine. But it's you have a door that closes. You can have some privacy, and you can be by yourself if you need to. There's also on the lower deck. That's where we have our prep room where we put on our analog spacesuits, because when we're at the station and when we're in the simulation protocols, we don't go outside unless we have a suit on for the duration of the mission. And I did that for 2 weeks last year during Crew 261 at the MDRS. The other buildings here that we see in this photo are the Science Dome is on the far right, and that's essentially a science lab with a lot of biological equipment and test equipment and microscopes and sample containers. You also, when we have visiting crews, they can bring their own gear and put it in there as well. Right above that to the left is the Musk Observatory, which was our original observatory. We now have 2, but this was the first one, and now it's a sun-facing observatory. On Mars, you would have to monitor for solar flares. So if a solar flare hits the Earth, we have the Earth's magnetic field to protect us. But on Mars, you don't have any magnetic field. You're unprotected. So you have to go get in a shelter if there's a solar flare coming to Mars. And so if we were living on Mars, we would have to keep an eye on the sun almost at all times. And and we did that during my mission. One of our crew members, our XO Aline, did some solar observations as part of just showing that this is something we would do on Mars. There's also a greenhouse. You can kind of see it there in the middle of the photo, right above 2 of the rovers. And generally we grow tomato plants and salad greens and herbs and other things the crew might consume during their mission. We are starting to do more research experiments in the green hab. One of the things we did during my crew was experiment using spirulina algae as a biostimulant for tomato plants, and measuring the effects of using algae as a sort of a fertilizer or stimulant for the plants. And it works. And it's a really interesting area of research for agriculture.
So the plants grow faster, right, with spirulina?
Yeah, think of it like you're giving the plant an extra booster in terms of its own health. And spirulina algae is one of the ways you can do that. It's called biostimulation.
Nice. And I see also you have ATVs, which you use for doing EVAs, extravehicular activities.
Yeah, we don't generally use the ATVs very much in Utah anymore. We have these other Polaris Ranger EVs that you see in the middle there. It looks more like a golf cart, kind of like an electric pickup truck, small vehicle. It's a 2-seater with a little flatbed in the back, but we can actually drive those with our suits on. And so it's like having a realistic moon buggy or Mars buggy when you're out on EVA. And we actually, during my crew mission, we went all over the map, around the station. We were going on EVAs that were 4 and 5 kilometers away to see different parts of the area that are geologically interesting, we flew drones over the canyon, the Candor Chasma area nearby. So,
and I know that geology of Utah is quite close to what we might expect on Mars, right?
Yeah, absolutely. I'm going to go to the next slide just to talk more about that. Mm-hmm. We found that this region of Utah, we selected it 24 years ago, around that, after a very exhaustive search of where in the United States we should put an analog station. And so we picked this area, but over the last 24 4 years, 22 years, it's been clear to us that this is a perfect area for Mars. It's extremely geologically similar. There's various terrain types, and it just looks like Mars. That area was always legendary for that, even before we were out there. That's one of the things that they talk about for the national and state parks nearby, is they look like Mars. So yeah, we're very happy about that environment. We've been able to use it for a lot of different purposes, not only scientific research. One of the recent areas we've been looking at is desert varnish studies, which is kind of how these biological processes interact with the desert. But also testing out equipment out there, because it's such a harsh environment. Stuff really falls apart, even stuff that's ruggedized. And so that was one of the things we did, is flew some drones that were designed to survive out there. Yeah, it's an isolated environment, so safety is always number one. We do safety drills. We do extensive training to make sure people know how to take care of themselves out there, make sure they're getting water and they're communicating when they have issues. That was a huge early focus of my crew, to make sure that we had a lot of rookies on the crew, a lot of people, it was their first time out in Utah doing Mars analog missions. And so we wanted to make sure everyone knew, like, hey, you need to, this is a serious environment. You know, if something happens, the nearest hospital is like 2 hours away. So you can't like flip a rover or something like that. It would be so dangerous to do that. And so we really pay attention to safety.
And most of the missions last 2 weeks, right? But occasionally you have the longer ones.
Yeah, occasionally you have the longer ones. Let me see if I have anything else to show here. Yeah, I'll just say for I know your mission, Mars 160, you guys stayed for 80 days, I believe, at MDRS. And there's been times when we've had a month-long crew, you know, maybe where there's 2 rotations during that month period, which is kind of an interesting way to do it. Because if you're doing scientific research, you'd be able to sort of do 2 weeks worth with one crew, reset, and do 2 more weeks with another crew, or maybe resetting, you know, experiment parameters or something like that. So, so we definitely are going to do more things like that in the future. In general, right now we have 12 to 15 crews a year, and each crew is about 2 weeks long.
And anyone can apply, right? Going to the marssociety.org website, and tell me about the options, how people can, you know, take part in these missions.
Yeah, absolutely. This is open for everybody around the world to apply for. We, in general, accept most people that apply, by the way. We schedule them out. We're scheduling out about 1.5 years out now for the station in Utah, for the Mars Desert Research Station. You can apply individually. You can apply, form a crew of 6 to 8 people and apply together that way. Or 5 to 7 actually would be a good range. There's 6 staterooms, and so the 7th person sort of gets the loft up above. Sometimes we can squeeze in 8, just depends on, you know, sleeping arrangements there. But, you know, but yeah, and then as far as the Arctic mission, the Flashline station, you know, that we do one of those a year at the moment, 1 mission a year. It's $20,000 per crew member. And we, in general, try to find folks that are going to do scientific research and assist us, or engineers that can help us operate and fix the equipment up there.
But for Utah, it's cheaper, right?
For Utah, yeah. For Utah, it's much cheaper. The cost for the Utah station for a professional is $3,500 for a 2-week mission, and $2,000 for a student to go for a 2-week mission. And we do have scholarships available in some cases.
Okay, so I guess folks should go to the website and you know, study it and look for opportunities, or for any volunteer opportunities also.
Absolutely, and if folks are able to partner with an institution like a university or another organization, a company or a government agency, to help sponsor their mission, that often is what people do to help pay for the costs of going to either of the 2 stations, and then they can bring the research projects for that company or organization. We are pretty much an open platform. Folks can come in and do their own projects. They retain their own results and can have data security of what they're doing on their own. We're just providing the research center as a platform for them to come and do work. But we reset it in between each crew. So everyone starts with a fresh campus that has, the water tank full, has all the spacesuits working nice and polished up and clean. And they can move in and do their work for 2 weeks and then hand it off to the next crew.
And dehydrated food, right?
Well, there's all kinds of food studies that we want to do. In the past, yes, we do have a lot of shelf-stable food, dehydrated food, so we often can get creative with it and make good food that you would have camping or that you would have doing some type of long-duration travel. Like back in the day when people were on ships going across the ocean, it's kind of that sort of mindset. Is they were able to do good food, yet in some extent they had fresh food and fresh ingredients as well. And so we do try to do some things like that. I mentioned we grow the greens in the green hab. So we were doing things like making tea with some of the herbs from the green hab at night, and also salad, greens, supplementing the rest of our meals. But we lived quite comfortably. My crew of 7. I had 4 people from France and 1 Canadian and 2 Americans, and so we were actually trying to outdo each other with cooking. After a while, I was making some dishes that were from New Orleans, Louisiana, here in the United States, which is sort of a merger of French and Spanish and American culture. And so some of the food was similar to what they were used to in France. And then they would make crepes and kind of educated me a little bit about Nutella and crepes and things like that. So it was pretty fun.
Okay, I was telling to everyone about analog missions that you live in limitations and etc. And you're now, saying that no, we lived pretty good, pretty comfortable.
We did. I think that crew that we had, that crew of 7 on my mission here, and this is them right here. We could have kept going. We could have gone all the way to Mars. I think after that 2 weeks, we were working together pretty well. It was 5 women, 2 men. We had folks that were really skilled at each role. We had a journalist that was amazing. She was doing really artistic photography and really profound journalist reports that she would write every day, weave in some narrative, but then weave in the events of the day into that. Julian, our engineer, was an amazing engineer. He was actually trying to examine our power system at the station, which is a solar array with a set of batteries, and try to make it into a smart grid. And so he was really trying to understand how it all worked and take notes on it, run around and fix things, then run back and write code. We had another engineer, Erin Kennedy, who was testing out a wind-powered rover. So she had this robotics expertise, and she built her own Mars rover that would be an experiment to go look for geysers on the South Pole with a rover that's like a big wheel that would just kind of get blown around over the course of months to try to see these geysers and photograph them on Mars. So yeah, and then other folks like Audrey, our medical officer, very skilled. She's a pharmacologist at University of Paris. She had a very thick French accent. So did my XO, Aline, and Julien and Cecile, the other 3 French crew members. And so we actually talked a bit about, communications protocols, talking over the radio, like not interrupting each other when we're talking inside the hab, because that was happening. And one person really didn't like that, so,
And can you explain what is XO and in general, the structure in the crew usually?
Yeah, it's sort of a space mission crew where you have a commander and you have a second in command, which is the executive officer, or XO. And so I was the commander. Aline Ducati, who's on the far left in this photo, she was the XO. She's a engineer for the European Space Agency in charge of pad safety at the Kourou Launch Center in French Guiana. And so she's working on the Ariane 6 rocket right now. She's hard at work at that. And she had analog experience from the Amadi mission that happened. She went to, I believe, the Negev desert for that a few years back for, I think, like a month-long analog mission they do out of the Austrian Space Society. And so, yeah, the 2 of us were the leaders, and we both had previous experience. I had a previous mission at MDRS as an XO as well. And then the rest of the crew were rookies, and they were just experts at their field. Medical officer, 2 engineers, a microbiologist, and a journalist.
And I know that it's also very important to have to write the journalist reports because Mars Society always emphasizes that how it's important the public outreach and for as many people as possible to understand the importance of Mars exploration and why this analog mission's been going on for so many years.
Yeah, I mean, what's really important that we do is we research the human factors challenges. We don't have the hardware that we're going to go to Mars with yet, so we can't literally test the spacesuits and the rovers and the buildings that we're going to have on Mars. So we have analogs of them. We have things that are just like them, but that are cheaper or sort of fake, so to speak, simulated. Our spacesuit is not actually pressurized, but we do have air blowing in the helmet, so you hear what you would hear in a real spacesuit, and it feels like you have a real spacesuit on. You're encumbered just like having a real spacesuit on. And so trying to actually go out in the field and do scientific research and work together as a team and use the radios and use the rovers and use other equipment, fly drones. We flew drones with our suits on, Julian and I, both at the same time. In fact, we did an EVA just to fly drones to get camera footage for Aline's documentary that she was doing. And that was actually my favorite EVA that we did the whole time. It was like 4 friends going to the beach. That's kind of what it felt like. But we were flying drones around Kendor Chasma, the 4 of us, and then drove back. It took about 2 hours. It was fantastic afternoon. But yeah, we're trying to combine, scientific research that we're doing for real scientific research to advance the field with a simulated Mars mission where you're experiencing what it would be like to operate on Mars.
And for those who would think like, okay, why we're continuing doing all these analog missions, not only in Utah, but all over the world, and already so many people did it, and what's new we can get there? Is there any point in continuing doing that? What would you say to them?
Oh, there's so much for us to still learn about how to work together in space, how to psychologically, how can you best put together a crew and have procedures where people can work well together in a harsh, isolated environment like that. And also long duration studies, like having people work together. A Mars mission, if you just sent a crew to Mars and they came back with chemical propulsion, it would be a 3-year mission. That's longer than any people have ever stayed in space. We've had an astronaut or 2 stay in space for a year, but we've never had a whole crew work together for 3 years, which is what they would have to do if they went to Mars. And so there's a lot we need to still learn about how people interact and the right composition and set of duties and set of activities for a crew to have to go to Mars and work effectively together. So there's that line of research, but there's also all the other lines of research that we need to do to get ready to settle Mars. And that's kind of what we work on at the Mars Technology Institute as well, that we started this year, is we're trying to incubate projects where we're actually developing technology for Mars that also would have commercial applications here on Earth.
Can you tell us more? What are the upcoming projects at Mars Institute?
We'll be talking more about that at our conference in a couple months in Seattle. We have an AI project we're working on and a biotech project we're working on. And so we'll actually have ways for the community to help us out, as well as to propose other research that we could do or that people could work with us on.
And I have a question from audience. Was the Martian movie shot at the MDRS?
No, it wasn't. It could have been, though. And we actually did an event, a press kind of event for that movie as part of it releasing. But no, I think it was filmed in Tunisia, if I'm not mistaken. So yeah, it definitely could have been, though.
Okay. I know that Mars Desert Research Station is open for, I think there was even IKEA campaign before and some advertisement that was shot at the station. So I know that you guys are open for any cooperation like that.
Oh, absolutely. We've had many projects where companies and other organizations have come in to use the station to do ad campaigns. We actually had a K-pop, a Korean um, uh, music band come and stay at the station as part of a reality show in South Korea a couple years ago. We've had other Survivor and Discovery Channel TV shows that had episodes filmed at the station, and advertisements, and also just people doing documentaries and people wanting to learn more about the Mars Society have come out. When I was doing my crew a year ago here, we had a British photojournalist that just kind of takes different does different photography projects about different topics, not really space related. He came out and did this profile about us that ended up in this blog in the United Kingdom a few months back. So yeah, just all kinds of opportunities for people to partner with us.
Yeah, and I'm so glad that, in order to apply for the mission, you don't have to be only like engineer or scientist or a doctor. You can be an artist, and you can propose your art project to be in a crew with this art project. So I think that's really cool, because we would need art on Mars.
Yes, we need everybody to go to settle Mars. Mars is not just for the billionaires and the scientists. Mars is for everybody, and we all need to start now preparing for a future where we're able to travel to the moon and Mars easily. That's coming. That's coming with projects like the SpaceX Starship and other projects around the world. So the transportation systems are being worked on to enable this future, and we're going to see it in our lifetime.
Yeah, and I know that your station is, it did prepare so many people for future Martian flights. But if you can tell me more about the challenges and conditions that it simulates that astronauts would face on Mars.
So some of the things that we experience as an analog astronaut are being in a closed environment with people for an extended amount of time. You have to kind of manage your own emotions sometimes. I had very deep emotions when I was during my 2 week mission. I was very excited, but I was also having other emotions like I miss my family, or there was a friend of mine that passed away that was on the last crew I was on, and so I was thinking about him a lot when I was there. That was another kind of emotional thing. And then when my team was working well together, just feeling proud and excited and happy that I was with them. So yeah, that those were things that I think astronauts all have to struggle with. Also, one of the things astronauts have to do is just run around and do a lot of stuff. Monitor experiments, fix equipment, run through procedure checklists, talk over the radio and repeat things over the radio. And so all those things and write crew reports, submit reports on what you're doing. Actually physically writing things, but also writing up things on a computer. Those were all things we did as analog astronauts that a real astronaut would do. And then some of the emergency things that would happen. We trained on how to get out of the suits really quickly in an emergency if we wanted to break sim. But we also trained on if someone was hurt out in the field, getting them back, quickly, or if someone was lost, going out and rescuing them. You had two people leave on EVA, then the rover has problems. You have to send another 2 people to go get them. So we practiced that as a safety drill.
And so I think it's also a lot of limitations. The lack of freedom that you're used to in your ordinary life. Like you can eat wherever you want, you can take shower whenever you want, and sleep when you want. So it's like basically here you cannot do what you want. It should be kind of assigned with the whole crew and with the schedule and limitations in supplies.
Yeah, it depends on the crew, really. It depends on what you plan to do, because I wouldn't say like you have to do everything. Like, there's definitely negotiation that's involved when someone doesn't like the tasks that they've been assigned, for example. there's always negotiation and pitching in by other crew members that can happen there. But yeah, you're right. Like, it is a very structured environment, and being on a crew, you're depending on each other for a lot of stuff. And so, often what happens is you do have a little bit of interpersonal conflict because of all that, because of the pressure, the schedule, just the fact that you're out in a hostile, isolated environment that's, in the desert, that's really dry, and everyone's getting dehydrated, has to drink a lot of water, keep on top of that. Or up in the Arctic, maybe it's super windy or, cold at night or things like that. So, there's definitely things that you have to suffer through and limitations you have on a mission like this. But that's what makes it so rewarding. That's what makes it, like, overcoming adversity is a great way to, like, build relationships with people and just have an adventure, right?
Yeah.
So.
And I think on Earth you can, slap the door and say bye, and you don't have to work towards this relationship and compromise or try to find the common ground. But in those kind of missions, you have to do that.
Yeah, I mean, there's definitely ways to escape. The campus is big enough that you could go find privacy if you are upset at everyone, but it's always better just to work things out. And that we were always, me and my crew were always very focused on getting along and making sure we were communicating well and checking in on people. We definitely had times where a crew member was upset about something and kind of sulking or off on their own. And we would just go bring them food or, like, go talk to them and things like that. And that usually solved whatever challenge it was. That's
nice. That's super sweet of you. So you were not like a super harsh, strict commander.
No, I was not. I was a servant leader. I was trying to make sure everyone worked well together, and we did.
Okay, I will ask a few questions from the audience. Second question, candidates from which countries are allowed to become part of the next crew?
We have no limitations on that.
Yeah. Well, the next crew is already booked, but I guess, I think a year wait list, right?
Well, you're talking about for Flashline.
No, for Mars Desert Research Station.
So if someone applies right now, we would schedule them out for next field season, which would probably be like the spring of 2026-ish, something like that.
I think the only limitation is to get U.S. visa. If this person can get this visa, then he can come and do the research.
Right. Yeah, we don't have any countries excluded by this program, and we've had people from all over the world. So
that's great. That's amazing, and I think it's a great example how the whole world should work.
I agree. Yes. We all should be working together to get to Mars and to settle space. Absolutely.
Yes, we cannot. I mean, I think it will be super hard for one country to go to Mars and to do it successfully and for long duration.
Yeah, I think it's definitely going to be an international mission, the first mission to Mars, and I hope it's got everyone incorporated.
Tell me, why is Mars such a significant target for human exploration compared to, Moon or other celestial bodies?
Oh, that's a great question. Mars is unique. Mars is a place that we could live and bring a whole civilization to. It's got everything we would need to make advanced technology and to keep the crew and the people living there sustained. There's water ice that's plentiful on Mars. You have carbon dioxide in the atmosphere, so you can make methane, you can make rocket fuel, you can make water to drink and air to breathe. And then you have all the rare earths, we call them, which are just meteorites that have fallen to Earth. So you have all that on Mars. You can make all the advanced electronics, plastics, and then you can 3D print with regolith, with the dirt and make bricks. So there's everything you need on Mars. Mars also could have life, Life, the search for life on Mars, in my opinion, is like the biggest scientific question and challenge of our time. If we found life on Mars, if we found microbial life that was fossilized or even alive now in the water table down below on the surface on Mars, that would be like one of the biggest scientific discoveries ever. we would look at how that life was close to Earth life and how it differed. And those gaps, those differences may lead to huge breakthroughs in pharmaceuticals and medical understanding. So, and just the nature of life itself and our place in the universe, like those are like super profound questions, right? That
Yes.
like the ancient Greeks and folks around the world would wonder about. Like, is there life out in the universe? We actually could go send a mission to Mars and find life. Like, to me, that's the number one reason to go. But Mars, unlike the moon's 3 days away, but there's a lot less resources on the moon, and you have less natural gravity. There's really no atmosphere at all on the moon, whereas Mars has an atmosphere that's about 1/1000th of the Earth. So you have a little bit of, of protection there. Mars doesn't have a magnetic field like the Earth, but also, like, why doesn't it have a magnetic field like the Earth?
Exactly.
It lost it, right? That's a mystery. Like,
yeah.
And solving that mystery is maybe going to help us understand the Earth better and how we can preserve the Earth for generations to come. So for all those reasons, that's why we should go to Mars. It's for the science and the understanding, but also like for the challenge of it too, the challenge and the adventure of it. If we had a program going to Mars, that would tell everybody around the world, if I study my math and science, I could go be part of that.
Yeah.
That would be a huge driver for people all around the world. And so that's why I do what I do, because I want to inspire young people to be space pioneers and to enter STEM fields and make the world better. So,
and I think I know that many space agencies now and many companies aiming for the moon, but I hope moon will be just the test bed for actually, going to Mars.
Yeah, you can do both. You can do the moon and Mars in tandem. It's not an either or thing, and we definitely want to go to the moon so that we can get the experience of operating in a planetary surface environment. We've only had ever 12 people go to the moon, and the last crew went in 1972. That was before I was born, so like, we need to go back to the moon and get that experience and prepare us to go to Mars. And we can test our Mars hardware on the moon as well.
Yes. And the funny fact about, not funny, but I think a very interesting one, that psychologists predict that when you fly to Mars, it's around like 7 months, right? With technologies nowadays. And they're afraid that the astronauts, the human being never experienced when you fly so far away. So you don't see Earth, but yet you don't see Mars. So you're basically like in an abyss. And they're afraid that this would cause psychological trauma or, panic attack among astronauts. So for me, it's also, I'm so curious when we have the real mission, what would happen even during the flight, not talking about landing on Mars and living there.
Right. No, you're totally right. It's like a huge psychological thing to be like leaving Earth behind and you can't even see it, it'd be like one analogy is going into deep caves where people go spelunking and go down camping in these deep caves in the Earth, and they're totally cut off from everyone, and they feel this sense of like isolation and yeah, like you said, the abyss. I'm in an abyss where nobody's ever been before, and nobody would ever come rescue me. Like that's. I think though we'll have crews that are hardy that can get through that, and I also think if you have the right, if you have a larger ship where you have a lot of people on it, then it's going to be more like going on a big ocean voyage with where you have activities on board. Yeah. And you have all these interactions with other people and, things you're working on, things you're doing that are fun. I don't think going to space is just going to always be like you're cooped up in a little space capsule. Going to space someday is going to be like going on a cruise.
I hope it will be like, the Passenger movie. They had this nice swimming pool.
Yeah. Yeah, I agree, but I wouldn't want to get, woken up prematurely on the way to another star like they did.
Yes.
That was not a good situation.
We have another question for you, James. Could you tell us, James, if we have a chance of colonizing Mars in the near future?
I believe so. I believe that once we have the transportation systems working operationally, and the lead one there is the SpaceX Starship, and we just had the 4th test flight of that system in the last week, and it was successful. You know, Mars is in our future. You know, once you have the Starship and systems like that, it's not going to be the only one. There'll be other systems. I know China is working on a similar Starship type system as well, a reusable system for the Moon and Mars. Once you have systems like that flying at scale, we're settling Mars. That's it. It's going to happen. We're going to have a city on Mars. And my prediction is we're going to have a city on Mars by 2035.
Wow, it's
I think it's
exciting.
going to be that quickly. Yes. And I think the first cruise will land on Mars around 2030.
That's optimistic, and I hope it will be like that, that you're a fortune teller.
And that's based on the development of Starship. If Starship it stays on track, if they're able to successfully do their refueling milestone. They're also talking now about scaling up Starship into a version 2 so that would have more payload weight. That if that system is able to be developed by 2030, then it's going to fly people to Mars.
That's amazing. Okay, we have a pretty serious question. Next one. So, do you incorporate precautions to prevent bacterial contamination from humans to possibly water on Mars in the training? How would you? How would the effectiveness of those measures be determined at the facility?
Yes, we do. We have water that we are trucking in from the town, and it's basically what we call tap water, well water. It's not necessarily fully treated. Usually safe to drink, but still we want to make sure it's 100% safe. So we have a filtration system that's built into the hab. So we fill the water tank outside, but then when people actually turn the tap on upstairs to get a glass of water, it's been filtered a couple times now with the system we have. And we absolutely pay attention to also when people go to the bathroom and making sure that they're doing that in a sanitary way so they're not spreading bacteria to other crew members, because we're all in this enclosed environment together. It's like 6 people living in a house together for 2 weeks without going outside unless you have a suit on. And to put the suit on, you're interacting with each other and touching each other and helping each other. So you're basically with these people. If one of you gets sick, you're all going to get sick, right?
Yeah.
In general. So yeah, I think we just, for the most part, we do pretty well. I think we keep everyone pretty safe there. There's not a lot of bacteria contamination. The stuff we do in the Science Dome with chemicals and whatnot, we also have a lot of safety procedures of how to dispose of chemicals safely and not do toxic things in there. Or if we do, we're very careful about handling that stuff and hauling it out when we're done, taking it out of the campus when we're done. So, but yeah, all those things are pretty standard procedures we have in the crew handbook. And then when there is stuff that's even more, like if there is some type of work we're doing that requires extra safety procedures, we just make sure the crew is fully aware of that before they start the mission.
Then what are the primary technological and logistical challenges involved in managing these 2 Mars analog stations? I know it's pretty different between Utah and the Arctic.
Yeah. So now you're talking about what's my job like
Yes.
as the executive director to sort of operate these 2 whole programs, not just the physical facility, but like, what are we doing for research and who's going to be on the crew and who's on mission support for both of the 2 stations, and how do we get logistics figured out? How do we order food and supplies and spare parts and replacement equipment? Well, we have a company here in the US called Amazon that's really great, that we basically can order whatever we need through that and get it delivered to the town nearby, Hanksville. And then we can bring that in. We also do just regular supply runs up to the nearest town, which is Grand Junction, Colorado. And then we just go to like the Walmart or the Home Depot or one of those stores that everyone else goes to buy stuff. We'll get that and bring that in. But that's outside of the crew. That's basically the program staff, making sure the station and the campus are up and running and well maintained.
I thought about, when we go to Mars, that soon there will be a delivery by Amazon to Mars. Astronauts will just order stuff on Amazon and destination is Mars.
I have a feeling someday it'll be like that, yes, and we will have Starlink on Mars too. That's already in the plans by SpaceX, I hear. So I think it's living on Mars is going to be pretty comfortable. I think when we finally get a city going on Mars and we have hundreds of people living there, and I think it's going to really quickly expand to have thousands once we get going, and I think you're going to have all the comforts of home. You're going to basically have an advanced technological society that needs to innovate to survive. So you're going to have the best, most talented people possible with every field working at their highest level. And so they're going to need the best facilities. They're going to need all the stuff all the equipment and supplies that they would need to do their work. So we're going to have to have a pretty solid logistics system to get there. And yeah, Amazon's a great example of one here on Earth.
Okay, so we have another question. Can you tell what training, education, and skills required to participate in analog missions?
Well, like we said earlier, this is for everyone. Now, some common things are, just being out in the desert or being up in the Arctic, just understanding that environment, understanding that you need to take care of yourself. You need to watch whether you're dehydrated or not. So you constantly just need to drink water and take electrolyte packets in your water. That's just a must when you're out in the desert, no matter who you are. But, there's various roles on the crew. We all learn the craft of putting on a spacesuit, but then there's people that will do things with the spacesuit on, such as geological, biological studies. Journalist is another role, using your camera or taking video while you're out there. And then astronomy as well. We have 2 observatories I mentioned. So we often have a crew astronomer that just goes and does that during the mission, may also participate in EVAs as well. So there's a lot of different skills scientifically, but also regular everyday people that have no scientific skills or background can do this. You can be a crew journalist or the health and safety officer or even the executive officer with no other scientific or engineering skills on your own.
But would you need to propose the research project or just a project, maybe art project, etc., in order to participate?
You don't have to propose a project. It helps, and it certainly will give you something to do while you're there. You don't want to just go to the station and not have anything to do for 2 weeks, So that I would recommend that people have some idea of a project they want to do while they're there and include that in their application, but that's not required.
And I think it's also important to have the knowledge of English language, right? Because it's the one that commonly used in communication and in working, especially if we're talking about international crews.
Not necessarily, actually, Anastasia. Like we do have crews that have done a whole mission in another language together. Now they may have a mission support person that's speaking English, so maybe when they talk to mission support, one of the crew, needs to know English. But I could very well see a group of 6 or 7 Russian speakers come to the station and do very well together, or any other language. And we've had folks from various Latin American countries many times come and use the station and not have many people that speak English or just operate in Spanish during the whole time. And for my mission, we had 4 French speakers and they spoke French, during the mission. And it was nice to hear. I didn't understand what they were saying all the time, but
maybe they were gossiping about you.
They probably were a little bit, yes.
So as long as one crew member speaks English, the rest don't have to know it, right?
I would say so. I would say, yeah, maybe at least one person that's going to come be on the crew should know English so that they can communicate with mission support, or they could potentially propose their own mission support resource too. Like that is an option too. So,
okay. And I know that in the past you've been a Microsoft engineer. And tell me what forced you to make this huge transition, and just a little bit more about your background.
Yeah, thank you. I did work at Microsoft for over 20 years, and I worked on a lot of different products like Office and SharePoint and Visual Studio, things like that. Um, but I always was a space person. I was volunteering for the Mars Society at night and on weekends. I was working on our websites and helping out with various things, doing events for STEM in Seattle, talking to people about Mars. Even when I was working at Microsoft. And I was known at Microsoft as like the Mars guy, the space guy. They weren't really doing anything space related at the time. Now they have a couple projects like Azure Orbital, which is like a ground station as a service product as part of the cloud platform Azure. But back then, yeah, it was kind of just my day job and paying the bills while I did my passion, working on Mars at night. And then about 3 years ago, I got the opportunity to become our executive director full time, reporting to Robert Zubrin, our president. And so I jumped at that opportunity. It's my dream job, and it's been a fantastic 3 years since I did that. And I'm really happy with how things are going at the Mars Society, and I plan to be here for a long time.
And I think your example is amazing to show to the young folks there that you start with volunteering, with giving all your heart and passion, but then you will for sure have payback, and just not being afraid to do that, and not being afraid to change your career path and go out of comfort zone, and just follow your dream. Even if at that moment it seems impossible and crazy. And I would like you to tell, to our listeners, your wishes, your thoughts, any, suggestions for them.
Well, thank you. I really appreciate the kind words. I hope everyone is as excited about exploring space as I am, and a positive future in space where we're going back to the moon and living on Mars and going off to the outer planets. There's other destinations in the solar system that are pretty exciting too, like the moons of Jupiter and Saturn may have life as well as Mars. Europa and Enceladus are pretty prime targets as well for scientific research. That's what excites me. That's what gets me up in the morning is the possibility of seeing those discoveries happen in my lifetime, and seeing people live in space and live on other planets in my lifetime. And we're right there. Like, it's going to happen. Like, I could taste it, so that's what gets me up in the morning. And that's what gets me so excited about what I do.
And if you can taste it, okay, the last question is, did you think about the name of the first base on Mars?
That's a great question. I think something that is uplifting and unifying would be a good name, something that is inclusive of all nations contributing to it. So maybe something like Unity, that would be a good name for it. Or maybe something like Alpha would be kind of Alpha based. That's kind of an interesting kind of science fiction-y name. And that was actually the first call sign for the ISS when the first American and Russian crew members arrived on Crew 1. They called it Alpha. So
I like Unity because I'm ambassador of a charity space project called Unity, and I think it's a great one. Apparently, we don't have the last question. That one wasn't the last one, so I think this one is the last, and we're soon will end. So why not to leave Mars exploration to rovers and other probes as for now, and concentrate more on human settlement on the moon? SpaceX, NASA resources are not endless.
I mean, that's a great question. Why go to space with people? Well, imagine you wanted to go visit Paris, France, and visit the Eiffel Tower. Would it be better if you went yourself or if you sent a drone? Which one's better for you if you want to visit the Eiffel Tower? Well, you'd want to go in person, right? You'd want to stand in front of it and see it and touch it and, have that perspective and that experience. That's why we want to go to Mars. But also, humans are going to be so much better at looking for life and looking for scientific discoveries and exploring than rovers are. for the same reason. We just have so many more capabilities when we're on the ground there than sending commands to a rover and waiting for it to come back the next day.
And we are faster.
Yeah, and also, we can think on the fly. We're adaptable. There's a lot more ground and we can cover and things we can do if we're there versus a rover. So it's really all about how serious you are about exploring and finding discoveries. That's what it is for me.
Thank you, James. And we have a comment from the audience. Thank you so much, James. We're thrilled about this, going to Mars soon. So you inspired our listeners. And we will see you in 2 weeks at our Zoom sessions. And I highly recommend to join us, and where you can, talk directly and ask your questions in a lively discussion on Zoom. So please come back to us in 2 weeks. And once again, thank you, James, for this amazing conversation, which left us all inspired.
Thank you so much, Anastasia. And thanks, everybody, for today. It was an honor. And I'll look forward to talking with you all again soon.